Awesome. So this time we're going to do the next part of our logarithmic and exponential functions. And basically what it means, guys, is we're going to do them when there's not base e. Okay, last time we did base e, and I told you it's because it's a little bit easier. Now we're going to do it when it's not base e. So first, let's start with our bell work here. So this is a question from yesterday. What are the two things that I'm mixing? Well, first of all, sorry, equation of the tangent line. So I need my pot, and I need my saw. Now my pot is 1, and then I plug 1 into this. If I plug 1 in, what did you guys get? Anybody get it yet?
5e.
5e, exactly. Well, not yet, because we're just plugging it in right now. Right? We're just finding like g of 1. Okay? Now for the SOT, yes, now I need product rule. So I need to find g prime of x so that I can find g prime of 1. So my product rule means I'm going to take the derivative of the first times the second plus the first term times the derivative of the second. And remember, we talked about how e to the x has this wonderful thing where even if we took the 1000th derivative, it's still just e to the x, right? Okay, so now that I've done that, I can find g prime of 1. So this is just going to be 4e plus 5e, right? Which means ultimately it's 9e. We all in favor of that? We all agree? Nobody agrees? That's terrifying. Does anybody agree? All right, let's go through it a little slower. 4 times 1 is 4. E to the power of 1 is e, so 4e. 1 squared is 1 times 2 is 2 plus 3 is 5. E to the power of 1 is just e. 4e plus 5e is 9e. Now are we all in agreement?
Yes.
Oh, good. Some of us are. Emilio, what's wrong? You liar. First you dissed me earlier. Now you're doing it again. You booed me. All right. So then if I write my equation, it's y minus 5e equals 9e times x minus 1. Amazing. Yes?
Does this only one number?
Huh?
Does this only one?
Yep, it's just 9e. All right, now we're going to do it for real. So last time we did this, we did it for exponential functions with base e. Now we're going to do it different. So if we say that f of x is a to the power of g of x, then f prime of x, and you're going to see this is very similar to what we did before. So it's still going to have the g prime of x, okay, times the original, so a g of x. Now here's the part that's new. Watch. Times the ln of a. Now I want you to think about that and see if you can tell me why it's actually the same as what we did yesterday. It's just that yesterday it's simplified.
Because the ln of a and a.
Yeah. Basically, well, kind of. Not the ln of a and a. The ln of a when a is e. Because what's the ln of e?
Yeah, that one.
Yeah, the ln of e is 1, right? Natural logarithm of e, that literally means that it's base e. So e to the power of what gives me e? 1, right? If I convert it to exponential. So we did this yesterday, it's just that this part wasn't there. That's all. All right, so let's actually try and apply it and see that it's really not all that bad. Okay, so we're going to use this one and apply it from the previous lesson, right? So what did we learn? That the derivative of this was simply going to be the derivative of the exponent, which in our case is negative 2 sine 2x. Thanks. E to the cosine of 2x. Do we agree? Excellent. Now, if we do it our new way, it's going to be the same. Negative 2 sine of 2x times e to the cosine of 2x times the natural logarithm of the base, which is e. And what is the base? What is ln base e? We just said.
1.
Therefore, it just kind of goes away. It's just 1.
So we never have to put it. So, Mr. I don't understand.
When it's base e.
Mr.
So
I don't understand why we don't apply this rule on the last lesson, like 3.4. Like
We did.
this one.
the ln.
We use like
I mean, that's what I literally just proved to you. right, is that we did. This one, we did it from yesterday. This one, we did it with this new rule, and we realized, oh, this is just
Okay.
one.
But it's always necessary.
Well, it's always necessary. The thing is, when it is base E, it cancels out, so it doesn't matter.
Ah,
So really, that's all it is. So that's why I taught you E first, so you can kind of get used to it without having to have that extra ln of E,
okay.
or ln of whatever base. So, if we want, we get to write same Z's. Somebody was asking me about that yesterday. Not you guys, because I didn't have you yesterday. I had you 2 days ago. But somebody yesterday was like, how come we don't get to write same Z's? You do. All right. So now we're going to find the derivative of these things where, if you notice, my base is not E. So it means I'm going to have that extra natural logarithm of the base. So it's still pretty easy, so we still kind of like these ones, because this is just going to be 2x, which is the derivative of the exponent, x squared, times the original, 4 to the power of x squared, times the ln of 4. So the only new step is that we multiplied by the ln of the base, the ln of 4. That's it. Otherwise, it's the same. Matthias, you good with that?
And what is that? Like,
Are you sure?
how do you find that
Kind
number?
of, okay.
Is it equal to-
Were you here yesterday?
No, I haven't come from
That's what I thought. Did you watch the video?
Is it like-
Mistakes were made.
what
Watch
is
the
that
video.
one of four?
So ln of 4 is going to be some ugly number, so we just leave it. Because what that means, like what this means, you guys, is e to the power of something equals 4. That x is going to be some horrible decimal. So we're just going to leave it as ln of 4. Because it's more accurate to leave it as the ln of 4.
And like if we're doing it with calculator, we use
Do you have the TI Inspire or the TI Inform? Then yeah, it'll probably give you a decimal. The Inspire, you can choose to do it either way. So. Okay, next one.
Can you explain again that question?
Well, let's explain the next one because it's the same idea. Okay? So this one is the same, except what did I add to it? Pertuse, what did I add to g of x? It's not just the exponential.
About
product.
Thank God for your friends. Hey, Pertuse? All right. So, yes, it's a product rule. So that means that I'm going to do the derivative of the first, which is 2x, times the second function, 2 to the power of 2x, plus the first function, x squared, times the derivative of the second. And this is where we got to be a little bit more, I don't know, pay attention, because it's the exponential. So the derivative of the exponent is 2, times the original, 2 to the power of 2x, times the natural logarithm of 2.
Can you explain that part again?
It's not.
I mean, not really, guys. The truth is, it's literally just this, sorry, up here. It's literally just this rule. It's always going to be, those of you that are asking, by the way, it's because you were not here last class. You should watch the video, okay? Because we did all of this except for the ln. So what you do is you take the derivative of the exponent, you bring it down in front. Then you rewrite the exact same thing. Notice that a to the g of x is the same as a to the g of x, right? And then the last step is to multiply it by the natural logarithm of the base, okay? So you're literally just going to follow this. That's all you're going to do. And I think it's written on my wall somewhere. I don't know where. If it's not, you guys can add it to my wall. But I think that one's on my wall.
Go down further.
So,
Why are you
because what's a product rule do? Add.
asking for?
Guys, we are done with the big three, which means that now we're going to be doing chain rule of product rule of chain rule, quotient rule. We're going to be mixing them. No longer is it just here's chain rule.
And Mr. On an exam, we shouldn't simplify that.
You can't. What can you do to simplify that? Like I could pull the 2 out front, but the only thing I could really do to simplify this, which I would argue is not really even simplified, is I could move the 2 numbers to the front and say 2 ln 2 times x squared 2 to the 2x.
But
I don't know that that's really simplified.
yes.
Like if there was a negative, I would say yes, pull it out front for sure, because we tend to make mistakes with negatives and think it's subtraction. But with this one, like I don't really care which way you write that. It's basically the same. The only thing I would maybe argue is this is a little better, because here you might be tempted to write 4 to the power of 2x, which is wrong, because you have to do exponents before multiplication, but it's the same thing.
Okay.
All right, let's look at the next one. So h prime of x This one has nothing fancy. There's no extra like chain rule, product rule, etc.
2
Yep.
times 5 to the 2x minus 3 times the log of 5.
Perfect. Exactly. Right? So we just take the derivative of the exponent 2, multiply it by the original 5 to the power of 2x minus 3 times natural logarithm of the base. Yeah, come on. Are you getting this? Or are you okay? You're just not writing, so I was curious. Just making sure, man. All right. Now my next one, I am mixing stuff up. What rule do I need to apply to this next one? Yep, product rule. So derivative of the first is just 1 times the second function plus the first times the derivative of the second function, which means, sorry. So the derivative of x was 1, so we just wrote 3 to the negative 2x. Then I'm going to multiply x, the original first function, times the derivative of the second. And this is where it's going to be a little bit more tricky. So the derivative of negative 2x is negative 2 times the original function, 3 to the negative 2x. And what's my last step per 2's? I'm going to keep trying until you can get one. Yes, ln of 3. Per 2's, are you okay?
Yes.
All right. Ln of 3, because the base is 3. Okay, base is 3. Now, this is a case where Pablo, I would pull that negative 2 out front, so we don't think it's x minus 2.
Yes.
So this one I would definitely rewrite, and I would write it as negative 2x times 3 to the negative 2x times the ln of 3. And you could also put the ln in front. It doesn't really matter. The key is to put that negative out front, because you don't want to think it's a
So
subtraction.
you like eliminated the plus. Or were you
Yep, because it would technically be like plus negative 2x. Easier to just say minus 2x. Yep, what's your question?
Right, the negative 2 times 3 to the negative 2. I just all before this is do I get to mark it wrong?
Like this?
No, before you do the negative.
Like this?
But including the log of 3. Yeah, like including the log of 3.
That's fine.
I don't get to mark wrong.
Means the same thing. No, it means the same thing.
And Mister, what did you do with the x?
Hold on. What?
What did you do with the x after the plus?
It's right here. I just put it after the 2 so that it's minus 2x instead of x times negative 2.
So you don't have to distribute it.
There's nowhere to, there isn't really anywhere. I did. Because all of this is one big term of multiplication. So I technically did distribute it. Miguel.
Sir, it's similar to the question that Pablo had. I don't understand, like, the x that is in parentheses in the first, like,
This one here, yeah.
yeah. Does that x like negative 2, or does it multiply everything in the?
Thank you for asking that, because that was a perfect example. Guys, this is what I just said, right? So I just answered that. Paulina just asked. So yes, it means that it's multiplied, which is why it became negative 2x rather than x times negative 2.
Yeah, but it doesn't multiply the others, like 3.
No, it did. This is Paulina's question, right? So all of these are multiplied together, which means it's one term. So I did technically distribute the x in, right? Because like if you look, negative 2 times 3 to the negative 2x times ln of 3, it's all one term. Because if we're multiplied, it's all a single term. So I did distribute it by putting it into the one term that's there.
Okay.
Does that make sense?
But you could put it if you want.
Kind of, okay. Guys, I can put it wherever I want. The order doesn't matter. Look. 6 times 2 is the same as 2 times 6. Do we agree? So the order doesn't matter. So put it wherever you want.
So as long as
Right?
you bring multiply.
Yeah. As long as it's all multiplied. Okay, that's the key. So, all right. Since that was a perfect example, let's make sure that we're listening when people ask questions, because I did literally just answer that. Granted, you asked it in more detail, so it's still fine. If you need clarifiers, I don't mind. But let's make sure that we're listening when other people ask, guys. Okay.
Oh my God, we see.
What, you hate trig? Why do you guys all hate trig? All right. It's not that bad, I promise. We all groaned because it was trig, but trig's not scary, so it's okay. So, we're going to find f prime of theta. This is a product rule. Benji, listen up. This is a product rule. So I need to take the derivative of this one first. It's an exponential, right? Which means I take the derivative of the exponent. What's the derivative of negative theta?
1.
Negative 1. Good. So we're going to get negative 2 to the negative theta times the natural logarithm of 2 times the second function, which is just cosine of pi theta, plus, so are we all with how I just did the first part so far?
No way.
Yes.
Okay, so I'll highlight it, okay? Look, the derivative of this is all of this together. Does that make sense?
And where is
And then the second part of the product rule is this doesn't change,
where
right?
did you
Because,
put the original?
well, now that's on the second part. I'm not done yet.
No. But you did.
The original of cosine pi theta. Now what I'm going to do is I'm going to do the first original function, so the 2 to the negative theta, times the derivative of the second. And Pertuse, what's the derivative of cos pi theta? Damn it. It's negative sine, good, pi theta times, it's a chain rule, yeah, which is, what's the derivative of pi theta? Yes, it's the same as pi x, right? So it's just pi. Now, again, if there's a negative here, I would say we should rewrite this one. So let's rewrite it. The first part doesn't change at all.
Sorry, is that the
One sec, let me finish writing, okay? I'm going to pull the negative and the pi out front. So negative pi, 2 to the negative theta, times sine of pi theta. Pablo, what's up?
I think it's a dumb question, but just to be sure, the pi on the end, that is the derivative of pi theta, I
Mhm.
put it between the negative sign. Yes, I put it between the negative and the sign.
That's fine.
Okay.
Yeah, because again, all these things are multiplied, so the order doesn't matter.
Why did everything become negative?
Because if there's a negative 1 here, right? This is why I always tell you guys, move the coefficient to the front, especially if it's negative, because otherwise you might think this is 2 to the negative theta minus sine, and it's not. It's times negative sine. So if we move the negative to the front, you're not going to make that mistake. So always get in the habit of moving negative coefficients to the front. Even if you don't move all of them, at least move the negative for your sake. Okay? All right. I'm going to do one more thing because I think you might actually see it this way. What do you notice is the common factor in both of these? 2 to the negative theta, which would kind of be the same as just being over 2 to the theta. So you might see it written this way instead, where it would be like negative ln of 2 cosine pi theta minus pi sine pi theta all over 2 to the theta. You might see it written that way, like in a multiple choice or something, just because that's a pretty simple simplification. So you might
And
see
if
that.
they give us both, which one?
They'll never give you both. No, if it's multiple choice, they'll never give you both of these. There'll be some slight difference. Yeah. All right, next one. Now it's quotient rule. Exactly. Exactly. See, I told you guys would be all like saying that to yourselves. So low, d high. So this is 5 times 3 to the 5x times the ln of 3. Right? Pertuse, are you having a hard time with that? Okay, so again, let's highlight it to kind of see. So this part here is all the derivative of that. Because I pull down, I take the exponent, which is 5x. I take the derivative, which is 5. Then I multiply it by the original thing, which is 3 to the 5x. Then the last step is multiply by the natural logarithm of the base, which is 3. Okay? So it's just that you got to do all 3 of those steps for an exponential. Now it's minus high d low, so 3 to the 5x times the derivative of the low, which is 1, all over low squared. And that's pretty much it.
We leave it like that.
There's, like, I'm not really sure there's anything super helpful to do there. I don't know. I think I would leave it like that. Like, you could technically do some stuff, but I don't think any of it actually simplifies it. All right, so h prime of x then. Low 2 to the 3x d high times 2x minus high d low. This is where it's a little more complicated again. So it's going to be times 3 times 2 to the 3x times. Perfect. It's not necessarily hard. It's just that there's 3 steps you got to remember. Are we getting there, Pertuse?
Yes.
Yes. This is our goal. Pertuse is going to get a question right by the end of the class. It's only because I ask other people and they can get it. I ask you and you're like, no, mister, no. You don't even remember my name. You're so lost. All right. Yeah, I don't think there's anything on that. Like, you could technically pull out the 2 to the 3x as a common factor. I am missing. There we go. Whew. I am missing something. And then there is something we're going to do for sure. Thank you. I got distracted. Squared. Okay, so now there is a common factor in the top. What is it? I just said it. 2 to the...
Yes.
Good. So, I will not normally do this, but for the sake of us all understanding, for now, we will pull it out as a common factor. So, 2x minus 3x squared ln of 2 all over 2 to the 3x. Squared just means times 2 to the 3x again, right? I'm writing it this way very much on purpose so that we can see that that cancels. And so our final answer is just going to be 2x minus 3x squared ln x, or ln 2, over 2 to the 3x. Does that make sense? Yeah? Awesome. Awesome. And I guess technically I should write h prime of x. There we go. Any questions? No? We're good?
No, yes.
Yeah.
Why do you never multiply? Like when you do the logarithmic rule, why do you never multiply the derivative of the exponent that you bring down with the normal? For example, in the denominator 2 to the power of 3x, why don't you multiply the 3 times 2 to the power of 3x?
Like, why didn't I multiply these two together? Normally I do. I didn't this time because this cancels. So I wanted to show that it's separate. But yeah, like you could take 2 to the 3x squared and you could multiply it in to here and get 2 to the power of 6x. Like that's the same. I just didn't do it because I wanted to show that this cancels. And I do it on some of the other questions. All right. So for what values of x would the graph of p of x equals 2 to the negative 3x have a normal line, whose slope is 2? If the normal line has a slope of this, what is the slope of the tangent? Good. Slope of the tangent is negative 1/2, right? It's helpful for us to always remember the difference between the normal and the tangent, okay? All right, so in order to figure that out, I basically need to take the derivative and make it equal to negative 1/2 and figure out where that happens. So remember how normally, what do we do? Normally we find the derivative and make it equal to 0. Why? Why do you want it to be equal to 0? No. Forget this question. Why do I take the derivative and make it equal to 0? When it's 0, which is when what happens? Critical points, right? Max and mins. So the only difference here is that instead of doing it equal to 0, we're going to say, hey, we want to know what is x when it's negative 1/2. That's the only real difference, okay? So we're going to do that. We're going to find this. So our p prime of x is going to be the derivative of the exponent, negative 3, times the original, 2 to the negative 3x, times natural logarithm of the base. And now I'm going to take that and make it equal to negative 1/2. And then I just need to start solving for x. Okay? So I'm going to take both sides and divide them by negative 3 ln of 2. Now I'm not going to lie, that's a little bit ugly.
Why negative 3?
Because I want the negative 3 to go away and I want the ln of 2 to go, because I'm trying to isolate that x. So the negatives over here will cancel, and I will get negative 1 over, or no, not negative. I just said it cancels. 1 over 2 times 3 is 6 ln of 2. Right? Because keep change flip, keep the 1/2, multiply by the reciprocal of 3 ln 2. So multiply it by 1 over 3 ln 2, which gives me 6 ln 2. Are we okay with that? I know I did a step in my head. We're good? I'm only getting thumbs up, so the rest of you should have spoken up. Okay. And that's equal to 2 to the power of negative 3x. Okay. How do I pull an exponent down? Logarithms. Logarithms. So I'm going to take the log of both sides. So the log of all this mess first equals negative 3x log of 2. Now what am I going to divide by to get x by itself? It's hideous. I'm going to divide by negative 3 log of 2. Right? Right? Okay. Did you like my scared, right? All right. And so really, guys, at this point, clearly you can see, like, if this is a written question without a calculator, we're supposed to literally leave it like that. That's my answer. It's hideous. If we wanted to, we could probably put it into a decimal by just punching all that into my calculator. Just doing it in my calculator. You don't understand logs. Okay. Although in AP Calculus, they usually want you to round to 3 decimals, so I would do that. Okay? So that's it. That's the value of x. Okay? Truth be told, you guys, you could probably do this a little bit easier with understanding some algebra with logarithms, but I know that literally since one of you just said you don't understand logarithms, that's why I tried to keep it as simple as I could. Okay. Why did I put it what? Huh? There's nothing squared. Yeah. This is log of 2. Oh, you thought this was log exponent 2? Ah, yeah, sorry. No, it's log of 2. Yep.
In what situation will we start off with the slope of the
I can't think of a practical reason right now. I'm sure there is one, but I can't think of one right now. Because it's when you want something that's perpendicular to your slope. So you want it to basically cancel out your rate of change. It's going to be something to do with flow rates in either electricity or water, people, because if you have the negative reciprocal, it'll cancel out the other rate of change. Yeah, like, I don't know, I can't think of a good example, but that would be the scenario. Guys, I have a name. All right, so now we're going to do the rule for logarithmic functions, okay? So when we did it yesterday, it was a little bit different, but you'll see basically the same idea. It was the same. So if f of x is log base a of g of x, then that means that f prime of x is going to be g prime of x over g of x. Looks the same so far, right? Right? Yes, okay. When I ask you a question, you're allowed to answer. All right. And then ln of the base. That's it. Okay? That's all it is.
That's it.
Yeah. So let's apply this to this question. Let's do this one like we did yesterday, which was simply going to be the derivative of that inside part of the logarithm over the original part of the logarithm. So it's literally just 3 cos of 3x over sine 3x. Right? The derivative over the original. Now, let's do it with our new fancy rule.
Why did you put that green?
Well, you forgot the log of the base.
Nope, because I'm doing it the way we did previous lesson.
Why did you put that green?
Because cosine of 3x, or sine of 3x, is a chain rule. Remember, all trig functions, guys, are chain rules. It's just that when we first learned them, it was like sine of x, and the derivative of x is 1. So we didn't really need to. All right, now we're going to do the same thing. So it's 3 cosine 3x over sine 3x times the natural logarithm of the base. What's the base? E. And what's ln of e? This is just 1. Okay? Now, I mean, technically, I guess, maybe we should change one thing on these. What could you simplify this, both of these two? Close.
10.
Close. What's cotangent? Because it's cosine over sine. So it'll be 3 cotangent 3x in both cases. Awesome. So, let's try a few practice now. So for this one, it's going to be the derivative of what's inside, 4, over the original 4x, times the natural logarithm of the base, which is 2. Now, I don't know about you, but I think I can simplify that. What could I do to simplify that? Yeah, the 4's cancel, so it's 1 over, exactly, I heard x ln 2 from Amelia, right? That's it. Beautiful, right? Isn't it simple and pretty? Guys, I'm pretty sure Pertu thinks I'm crazy. She always looks at me like I'm a crazy person in class. All right. So, to be fair, both of her older sisters used to do the same thing. So, look at me like I was a crazy person. All right. So, g prime of x then this time is going to be the derivative of sine, which is cos, over sine times the derivative, or not, times ln of 3. I mean, technically I could simplify that. So, exactly, cotangent x over ln of 3. Guys, I heard you say también. You guys not understanding something? Are you okay? You're both good? Okay, I was just making sure. Because if you're agreeing with the fact that somebody else doesn't understand, I want you to ask. But if not, we're good. Benji?
It might seem like a tough question, but like in the exam, can we just leave it like you put it on top, or do we also have to keep simplifying it?
The general rule of thumb is if the simplification actually makes it simpler, like it, you know, in this case we took cos over sine and made it just cotangent, you should probably do it. If it's written. If it's a multiple choice, you're going to have to look for what the answers are, and you may have to do some algebra to make your answer match. Right? So, yeah.
We have to do this for all items.
I mean, yeah. I mean, I'm not going to give you a ton of like trig identity stuff because I know you guys didn't really learn it much, even though you were supposed to. Sad day. All right, let's do the next two. Or do you guys feel like you could try them? You want to try the next two on your own? Yeah? All right. I'm going to give you like a minute to try them, and then we'll do them together. You guys all had a minute to try them on your own. Let's see how well you did. Check your answers. Now, you'll notice I did some simplifications. The first one I think you probably got. It was pretty easy, right?
Why, but I still don't understand why you pull out that green.
Okay, so it's a chain rule. So cosine, that's a terrible cosine. Cosine of 3x, that means the derivative of the outside is negative sine times the derivative of the inside, which is 3. When I'm doing trig functions, I tend to just do it all at once and move that to the front. That's why I wrote negative 3 sine 3x. Because I just do it real quick at the very beginning.
No, me too.
Okay? You weren't here, that's why. You went to the bathroom for 20 minutes.
No, I was with Paul.
Oh, you're right. Well, you're still gone. Anyway, so guys, what we do is we do that derivative of the cos 3x, which is negative 3 sine 3x over cos 3x, multiplied by the ln of the base of the logarithm, which is 5. You should probably simplify that because sine over cosine, as long as the arguments inside are the same, is just tangent. Now, the next one is a little bit trickier. You have to remember two things. One, Pablo already pointed out, right, is that if we have logarithm and we don't say what it is, it's always base 10. You have to remember it's base 10. So this is 3, because the derivative of the exponent is 3, times the original 2 to the 3x, times ln of the base, which is 2, for the exponential, divided by the original, which is 2 to the 3x, times ln of the base of the logarithm. Okay? This one's the base of the logarithm, this one's the base of the exponential, and then, of course, the 2 to the 3x cancels, and you should just be left with this. Make sense? Good. All right. We can do it. One more page. I think we got, what, 3 problems? Oh, 4 problems. I think we can do it.
Can you go up one second?
Oh my goodness. Yeah. So, the next one is going to be everyone's favorite rule. And that's, yes. Because that's your favorite, because you love chain rule, because it's easy.
I love quotient.
Really? I hate quotient rule to the point that I never do it. I write everything to the power of negative whatever so I can do a product with chain. Oh. Happy for you guys. Okay. Ladies and gentlemen, let's do it. Okay? So, I'm going to think about rewriting this as log base 7 of x squared minus 1 to the power of a half. Okay? So, the derivative of that thing up top is going to be 1 over 2 times the square root of x squared minus 1. Why? Because I know that 1/2 minus 1 gives me negative a half, so I'm going to just slam it at the bottom right away.
And why don't you put it in parentheses 1/2?
Same thing.
Square root. But which one is easier?
I don't know. Square root's easier to look at, to read, but I would say 1/2 is easier to do math with. Okay? And then I need the derivative of the inside here, which is 2x. So I'm going to put a 2x on the top, which means that my 2's go away. Amazing. But that's only the numerator. Now it's all over this original argument inside. So the square root of x squared minus 1.
Why?
Why? Because it's always over the original argument that's inside the logarithm, right? Times ln of 7. Now, this is where, of course, we've got a fraction of a fraction. So we're going to change that, and we're going to rewrite it as keep, change, flip. Exactly. This is technically over 1, so we're going to make it 1 over. And we're going to do that on purpose because what do you notice is going to happen to these two roots?
They cancel.
Yeah, exactly. So we're just going to be left with x over x squared minus 1 times the ln of 7. And that's it. I heard somebody say they're lost. What are you lost by? No? One of you guys said lost, no?
I said, but
So tell me, man. Don't like just say it.
no, I asked him. I was gonna ask like for the chain rule when there's square roots. I don't like.
Okay, so if that's fair. So if it's hard for you to do it all at once, do it in steps. So instead, you could write it out as like 1/2 times x squared minus 1 to the negative 1/2 times 2x, the derivative of it, and then crunch it all together. So if this is easier for you, do it that way. I do it all at once, but you don't have to. Like if it's easier for you to write step by step by step, then move this to the bottom and cancel out the 2's, you're going to get the same answer.
I
Okay?
think that's
Yeah, so if that's easier, do it this way, and this is more steps, but easier. Okay, let's jump down to the p of x.
What's the derivative of sin x squared?
Well, it's technically not sine x squared. It's sine x squared. Oh, no. Sorry, I was thinking you were asking sine squared x. Okay, let's do it. And then you'll see. P prime of x is going to be the derivative of this, which, because it's trig, is automatically what rule?
Chain.
Chain rule. Who said that? Good job. Yes, so it's going to be chain rule, which means the derivative, I like to do it all at once, but you don't have to. The derivative of the inside is 2x, right? Times the derivative of the outside. Now, technically it's the derivative of the outside times the derivative of the inside. If they're multiplied, does the order matter? No, this is why I so often do the inside first, right? Because the order doesn't matter, and ultimately you're usually going to put it out front. All right, then it's all going to be over sine of x squared times the natural logarithm of 2. Now I can do something with cos over sine. What should I do?
Cotangent.
Exactly. So I'm going to get 2x cotangent x squared all over ln of 2. Because again, that's a simplification that definitely makes it easier, so you should do it, right? Cosine over sine is the same as cotangent. You should make that jump. Now, you could probably guess the next one's a little more work, which is why you've got more space. So let's do some extra algebra with our derivative, right? It is quotient rule. Apparently that's all your favorite because y'all are crazy. So you're not crazy. You're just different from me. That's all. All right. So we got to do the derivative of the inside thing first, which is going to be low d high minus high d low all over low squared all over, right? Because that's just the top part. Like that's the derivative of the inside, which is the top part of the logarithm. So now it's all over 3x over x minus 1 times ln natural logarithm of 3. Now, keep, change, flip, right? So q prime of x is going to be this first thing, but let's simplify it. So what's 3x minus 3x?
0.
Thank God. Right? Because if I distribute this 3 in, I'm going to get 3x minus 3x that cancels, but I will still have the negative 3. So I'll have negative 3 over x minus 1 squared times x minus 1 ln of 3 over 3x. Now, what cancels there? A bunch of stuff. X minus 1 will cancel with one of the ones on the bottom, so we just cancel the squared. And the 3 cancels with the 3 to make this one like negative 1. So in total on top now, I have negative ln 3 over x minus 1. Or if you prefer, x squared minus x. Doesn't matter. Does that make sense? Wait, I missed something, didn't I? No, I didn't. No, I didn't, because the ln 3 was on top. Okay. Sorry, who's not done? I want to try and get the last one. We got like 3 minutes. You know, if you hadn't booed me, we'd have time to be done. Okay, here's what we'll do then. Because we're going to have a weekend, we will leave it. So last one here, we've got h of x is log base 2 of x over 2x plus 1. And it's got a tangent line whose slope is 5/2. So we got to figure out when that's going to happen. Meaning, we need to take the derivative, and then that derivative needs to be equal to our 5/2. So h prime of x is going to be, we're going to have to do quotient rule here to get the top part. And so we got low d high, which in this case is 1, minus high d low over low squared, all over the original function. So then from there, we can simplify that out a bit. So up here, we got 2x minus 2x. So those are going to cancel because it's just times 1 here. And then we got 1. So now we've got 1 over 2x plus 1 squared times, because we're going to keep change flip to get this fraction of fractions gone. So we're going to flip this one on its head, 2x plus 1 over x. And so one of those 2x plus 1s will cancel. And so we get that h prime of x is equal to 1 over, oh, hang on, I missed something. This should have been ln of 2 as well, which would mean that the ln of 2 ends up here. My bad. Okay, so then it'll be 2x plus 1 times x times the ln of 2. Awesome. Now, that needs to be equal to 5/2. multiply this out a little bit here. So 2x squared plus x times the natural logarithm of 2. Then we're going to have to multiply to get our x's up on the other side there. So we're going to multiply both sides by 2x squared plus x. And so we're going to get 5 times 2x squared plus x, because I can't solve for a variable if it's in the denominator like that. It's equal to, I'm also going to multiply both sides by 2 to get rid of that. So I got 2 over the ln of 2. Now, at that point, I would probably just put this in my calculator. Probably the easiest way to do that, though, is actually to move it all to one side. And so go, let's see, if we multiply it out, it would be 10x squared plus 5x minus 2 over ln of 2. And that's equal to 0. Put that in our calculators. We're going to get that the answers are negative 0.842 and 0.342. And so that's going to be the two places where our slope will be equal to that. And that's going to be it, guys.